Okay, so the 2017 set, guys. Let's start with the last question. It says the equation for the preparation of hydrogen chloride using concentrated sulfuric acid is shown. It's absolutely shown, and we've done this reaction multiple times, and we've seen it even in chapter number 4 in inorganic chemistry. And so it says use Bronsted-Lowry theory of acid-base theory to identify the base and its conjugate acid in the reaction. Explain the answer. We know, see, H2SO4, it's a proton donor right here. It donates a proton, and so the Cl accepts it, and it becomes HCl on the right hand side. So H2SO4 is the acid on the left, and this is my baserino because it accepts a proton right here, and this donates a proton. And on the right hand side, HSO4 now, because the acid has donated a proton, this HSO4 now does not have, you can think of it as not having the ability, although it can, but you can think of it as not having the ability, and therefore it becomes the conjugate base, and HCl now has the ability, it has one extra proton, so therefore this is my conjugate acid. So if you were to ask, if the examiner asks me the Bronsted-Lowry base for it, that's Cl1 minus. Why am I not writing NaCl? Because Na and Na, they are just spectator ions, doesn't really make a difference. And conjugate acid for it is what? HCl right here. That's the conjugate acid. And the examiner was kind enough to give you guys the option of writing the base as HSO4 minus and writing its acid as H2SO4. So you could have also written this right here, HSO4 minus and H2SO4. It's up to you, whichever you wanted to prefer. But in my opinion, Cl minus and HCl is the better version for it. And what's the explanation for it? Sir, Cl minus is the base because it accepts a proton. So Cl minus is base since it accepts a proton, and why is HCl the conjugate acid? Because now it has one extra proton, one extra hydrogen ion, or one extra proton or hydrogen ion. It's up to you, whatever you want to write, because once it has one extra hydrogen ion, it now has the ability to act as the acid. That's why we call it conjugate acid. And you could have written similar definition, a similar explanation for HSO4 minus and H2SO4. That's it. We are done with the entire sets for acid-base equilibria.